data breach, what I mean is that you don't want to, you don't want people to have access to your info, mainly the info you keep in your database. You want people to have access to it. So we can see here, this is an example of something that happened a while ago. There was a rumor going on that LinkedIn data was leaked, right? So this here is the person trying to cash out on the leaked information. This is what the information could look like, right? So you can see they are leaking people's full names, their email, and all of those things. This information can be useful to people who want to spam your email, for instance, or they want to just send you ads, right? For example, you are there, you receive an email that's you've won something, so click on a link, those kind of things, right? This is how they get your information. So we want to prevent these kind of things. If you are a business and you end up leaking your information, nobody trusts you anymore, you lose business, you're out of the game, right? So we don't want to do that. So how can we make sure that we make it difficult for people to get access to our data, right? Now, we can no system is 100% secure, right? But the point is we want to make it difficult for people to get into your system. We want to make it take a while. You want to delay them, right? To make it discouraging for people to try and enter into your system. So for this talk session, I'm going to take you through encryption, authentication, and data validation. There's a lot more you can do, a whole lot more, but because of time, we'll just stick to these three. So we'll start with encryption, right? The whole point of encryption is that you don't want to make your network traffic, the data you have in your network traffic, you don't want to do that in plain sight. So say someone logs into your system, the person provides like an ATM number, for example, you want to pay for Netflix and you enter your card details. You don't want to send those details across the internet plain, right? You want to encrypt it. You want to make it gibberish. So if anyone sees it, it won't make sense to the person. So that's the point of encryption. And then for encryption, you want to use a protocol called SSL or TLS, right? TLS is actually the updated form of SSL, but then people really interchange them. So you see this around a lot, SSS/TSL. Yeah, so that's the protocol used to encrypt your traffic so that it won't be in plain sight, right? Now, for you to be able to get this done, there's something called an SSL certificate. The SSL certificate is what is what allows you to like encrypt the whole thing. And if you have like an SSL, if you have an SSL certificate, I think most of you have noticed by now that there are some websites, you visit the website and then it goes like HTTPS. It starts with an S, HTTPS, and then you have some that are HTTP. So the HTTP ones are the ones that are not encrypted. Those ones, when you send your data like that, you see the data you're sending. So any hacker can just sniff the packet and see what you're sending over the internet. But the HTTPS means it has an SSL attached to it. So the certificate, you can get a certificate in two ways, right? The one can be self-signed. You can sign your own certificates and generate your own certificate and sign it. The other one is to be signed by a certificate authority, right? So if you usually use a self-signed certificate if you are like trying to do a proof of concept, you are testing, but when you go to production, you have to use one signed by a third party. That's called a certificate authority. So I want to, so let me explain the process the SSL goes through, right? So if you have your API on the server, and you're ready to receive traffic, right? So someone enters https nike.com, example, you want to reach Nike. When you send that request, the browser is first going to tell the server that's, hey, I want to communicate with you. And the server goes like, okay, you want to communicate with me over HTTPS. So the server sends its certificates and then its public key to the browser. the browser will now go and authenticate the certificates, right? So the browser wants to know if the certificate is actually valid or if the person forged their own certificates, those kind of things. So the browser will find a way of certifying if the certificate the server sends is authentic. If the browser is able to assess and verify that the certificate is authentic, what's going to do is that it's going to it has something called a symmetric key. So it's going to have like two keys, like those two red keys down there. It's going to attempt to give one of the keys to the server, right? But before it sends the key over the internet, it's going to use the server's public key to encrypt its symmetric key, one of them. So it's going to encrypt the key and send the key to the server. And the server uses its own private key to decrypt the key. So at the end of the whole communication, the browser has one key, the server has the other key, and the keys are the only thing that can encrypt and decrypt the data that is traveling, right? So that way, if the browser is sending any information, it's going to use one of the keys to encrypt it. Then the only way you can get the actual meaning from the message is to use the key to decrypt. So the server will be able to decrypt. That's how the SSL thing works. I was able to come up with a short demo to demonstrate how this thing actually looks like, right? So to be able to create create your own SSL certificates for demonstrative purposes, you can get this set of code at this link here. I'm sure it's all over the internet. You want to generate your own certificates. These commands are there. So you run them and then to generate the certificates for you. But when you're actually generating a certificate, they'll ask you for some information like your domain name, your email, and some other important stuff to ask you. But it's not anything difficult. I've already done that, so I don't want to go through that process again. But yeah, so I want to demo how this thing looks like. Yeah, so I have a very simple app here. So this one is one without, it's an HTTP server, right? It doesn't have any encryption. It means if you communicate with the server, you're going to expose everything. So it's very simple. When you create a request to the server, it's just going to return hello world, right? The hello world, because it's HTTP, is not encrypted. Everybody will see it. So let's test that out. So we have, yeah, it's ready. We have our Postman. There you go. Postman is used to send, it can act like a front end for you. You should test your back end, right? So I'm going to send a message. I'm going to try to reach our server, right, from Postman, and then we'll verify that we can actually see everything. Okay, so this is our endpoint for the HTTP server. But before I send, I'm going to start sniffing the packets, right? So we are sending in the request now, and we are stopping the Wireshark. Wireshark is used to analyze network traffic, right? So if we try and see what's in there, you can see the hello world, right? So if it was someone's password, someone's credit card number, it's very easy for a hacker to see it because it's not encrypted. Now let's try the one that is encrypted. Yeah, so this is a code base for the encrypted server, very, very simple one. To use the HTTPS, you generate the commands I showed you. It's going to generate two files. One file is called a set file. The other is a key. So this is a certificate and this is a key that you get from generating the SSL, right? Then you're going to find the two files, right? You're going to use a FS is file system, right? It allows you to read and read files, right? So I'm going to read the key that you generated and then the certificate that you generated, right? And then when you create, you use the HTTPS create server, you pass in those options. And basically this is going to generate an HTTPS server. So everything is going to be encrypted, right? So I'm going to try and reach this endpoint and see that you can actually not see the hello world like you could previously. So again, Wireshark, this time around we want the TLS info, right? And these are endpoints for the HTTPS. You can see the S here. So, oh, I've not started a server. Let me start that. Yeah, server is running now. Yes. So we stop Wireshark. So you can even see the process we're talking about, how the SSL works. So the client sends a hello to the server sends a hello back to the client with a certificate down there, right? Then they exchange the keys and go through the whole process. But if we try to look at this guy, realize that everything is gibberish. You literally can't make any sense out of it. You can see bits and pieces like Accra, but you really can't see. This information is like the domain name. And basically these things were asked when you're creating the SSL certificate. So those ones, they are public, it doesn't matter. But then basically you can't see the hello world, everything looks gibberish. So a hacker cannot sniff, they can't sniff the packets, just cannot make use of this info, right? So we have our SSL being the first thing to consider. Well, it's not the first thing to consider, but it's an important thing to consider when you are building an API. Let's go to the next thing. So the next thing is authentication, right? So for authentication, basically when you hear authentication, it just means you want to verify if the person is saying they are who they are, right? So for this, you can imagine you're living with your parents, right? If you're living with your parents, you can imagine that your mom is authenticated to enter the house. Your mom is allowed to enter your house, but a stranger or your neighbor cannot just enter your house. Your mom is authenticated to enter your house, a stranger cannot. Usually you hear these two terms, authentication and authorization, right? Authorization just means that who is allowed to do what, right? So you can allow your friend into your house, but a friend is not allowed to maybe go and sleep on your mother's bed or just eat from the fridge or go to the kitchen. And like there are things, there are rules. You can't just do anything, even though you have access to the house. There are rules, right? So we are going to implement this authentication with something called a JWT. That's a JSON Web Token, right? So what this is going to do, okay, I give another example here. Over here, when you usually are going to swim, I've been to two places and they do that. So I wanted to use that example. Like when I'm going to swim, you go to the reception, you pay, they give you a band on your hand to show you've paid. And then when you are swimming, anybody that's attending to the area knows that you've paid. So you can't like have people sneak into and swim. So the JWT is like the band you have on your hand that verifies that, oh, this guy has paid, right? So yeah, so that's about it. And we use a JWT in a production environment. Yes, so let's go straight to a demo. Come to show the code base for this one. Please, if you have any questions so far, feel free to raise your hand and ask, else I'm continuing with the next part. So we have this also very basic API, which implements the authentication and some authorization and also some data validation. Let me just take this opportunity to go through data validation. So whenever you receive any data, right, from a client, right, you are supposed to validate the data. What the validation means is that you want to sort of make sure that it is what you are expecting, right? So even if you give someone a field to enter their password, right? Or a field to enter their password or a username, you don't expect users to always enter the right thing. Some people would not know what to enter. Some people know, but just want to try a system and find loopholes, right? So if, for instance, you're asking for an email, you want to make sure someone's not writing a full sentence, for instance. You want to make sure that if you're asking for an email, the email you are getting has like an @ sign. I don't know of any email that doesn't have an @. You have like an @ you have the dots, maybe .com or something. So just check all of these things, make sure it's not empty and all those things. That's validation. Yeah, so now that we've covered that, this is a Node.js server based on the Express framework. So what's happening in this server here is that we have the framework, we are instantiating it in the app, and then we are using it basically. So this is where we start our server, right? And it's an HTTPS server. As usual, we've already covered how to create the HTTPS server. Very similar. We have our key. These are our sets and our key. And another important thing is that when you create your sets and your key, you make sure you don't push them to a GitHub repo, right? If you push your key, it's like you buy the best locks for your house, and when you're done, you leave your keys outside. It's almost as good as not even locking your house, right? So you want to keep this thing private, you want to keep it secured, make sure nobody has access to it, because when they have access to this, it's like you didn't even secure your whole system, right? So back to the server. So we have those options. We pass them to the HTTPS or create server, and then we console log when the server is running, right? So I'm starting the server. Yeah, these things always have a way of. Oh, okay. The port is being used. Let me just stop the other. Yeah, and this API is using MongoDB as a database, right? So it's basically just going to have the login register functionality, and then we'll see how we can secure API, right? So the login is what you're going to use to authenticate, right? Before someone's allowed to use the API, I want to authenticate, I want to make sure that the person is allowed to use the service or the server. So we have like a register. Before you can log in, you have to register first, right? So when you hit endpoint, the register endpoint is going to use this general app.use, right? Use this route and it's going to kind of import this middleware, right? So this middleware is in auth.route, which is here. Basically, for the register, it's going to map all the way here, and it calls this post request to another middleware I created. That's a register middleware. So the long and short of it all is when you hit the register endpoint, this is the actual logic that is going to be run for the register. So the very first thing is going to read the request body. The request you are sending from the front end is going to read the request body. For this app, I'm accepting a username, a password, and then a role if you are an administrator or not, because we don't want to do some kind of authentication, right? You don't want to allow the basic users to do the things that the admins will do and whatever. So I'm requesting for these 3 parameters from the body. Now, when you get these 3 parameters, the very first thing you do when you receive anything from outside the system is to first validate, right? So this is a very simple validation. In fact, there's more you can do to validate your data. This is just an example, right? So for example, I'm just checking to make sure that the length of the password you are submitting is not less than 6, for instance, right? You don't want anybody to send like an empty password or a password with 2 characters or something. So it's a very simple validation. You can have a very long one that checks so many things. But yeah, that's for the register. Then we are wrapping the logic in a try catch block. I'm not sure if you've already come across a try catch block, but basically, if you have any code that can cause an exception, you wrap it in a try block. If there's an exception, the catch is going to catch the exception. So it doesn't crash your system, basically. You want to direct how things go badly, for lack of better words, right? So that's what the try catch block is. So this, because we are going to be working with our database, anything can happen there. We can have things that are unpredicted to cause the whole action to fail. So wrapping that's in a try catch block. That's the whole point of the try keyword you are seeing here. And then the catch down there, the catch down here. Yeah, so the first thing we are doing is that you are trying to, no, this is a login, sorry, we're in the register. So the first thing you're trying to do is that we want to make sure you are passing in something, right? Now that we are sure you are passing in something, the next thing we want to do is we want to store the data. These are a good point. So we are sure we are using HTTPS. So the password we are sending from the front end to the back end is secure. Nobody can read it at this point. So the next thing to do is that we're going to also send it from our API to our database. What we want to do is I want to make sure that it's also secure at that side, right? From our API to our database is not HTTPS connection. So as to make sure we are securing it at that side. So what we usually do with passwords is that you're going to encrypt the password as well. So you're going to convert the password, make it like gibberish, right? So that people cannot read it. If they get access to it anyway, it doesn't make sense. And they can't necessarily use a password to log into the system, right? So we're going to encrypt it first. But another problem that comes with encryption is that when you hash a password, right, they all hash to the same length. I can provide a specific length that I'm going to use hash a password. Let's say if you hash a simple password like Bluebird. Let's assume I'm trying to register and my password is Bluebird, and you hash Bluebird, and assuming you're going to get like 16 characters of random strings, so it's going to look like gibberish, like 16 characters of them, right? Now, if someone else hash, what happens with the hashing is that no matter the length of the password, you get the same length of a hash. So if someone's password is Bluebird and then the hash length is, for example, 16, someone's password can be I am going home. That one too also hash to 16. Someone's password can be a full paragraph. It will hash to 16. It can be a full book. It will hash to only 16. And the thing is that the hash is unique. So two people really cannot, it's very, very rare for two strings to get the same value. But the problem is that if you want your API to be scalable, right, it's likely you can have like a number of people choosing the same password, right? So let's say I'm in Ghana, my password is Bluebird, someone else is in anywhere, their password is Bluebird. What's going to happen is that when they hash the passwords, we are going to have the same hash, right? The password won't be seen, but the random strings will be the same for me and that person because we use the same inputs for the hash function. Now, this makes it easier for hackers because if they get a hold of the data in your database, right, and they look at it and realize that there are a number of people who are having the same hash, It basically means that it's giving them less work to do, because if they're able to figure out the password for one person, they automatically have figured out the password for all those people who have the same hash. So we want to make things difficult for them, so that if they have to use, for instance, 1 hour to crack somebody's password, you have to use an extra 1 hour to crack another person's password. So we just want to delay them. Hopefully, before they are able to complete everything, we'll find a remedy, right? So we want to delay the whole process. But if you don't, if you just hash the passwords, what's going to happen? You're making things easier for them. So the mechanism we use to fix this kind of situation is that when you get the person's password, right, you're going to add something called a salt. A salt is just a random string that you generate, right? You generate a random string, add it to the person's password and hash it. So what's going to happen is that if my password is Bluebird, someone else's password is Bluebird, we are both going to have random salts generated together. If it's hashed, there's no way our hash will be the same. So we're making things difficult for the hacker, right? So that's the whole process of securing a password. You hash it with the salt. And then there's this bcrypt library that you just require. You install the dependency. So you install it and then you instantiate it and you start using it here. It has this hash function. Fortunately for us, the hash function does both adding of the salts and then the encryption. So you don't have to do it yourself. Just call the .hash function, pass in the password that is coming from the front end, and then you pass in the salt rounds. The salt rounds are something we call the cost factor, right? So what's this function is doing is it's going to hash a number of times, a number of iterations. So if you have Bluebird, it's going to convert Bluebird into a random string, then to convert it again and again and again. Now, the number of times it's going to convert is dependent on this number you provide, right? It's going to convert 2 raised to the power this number of times. So if I'm passing in 10, it means it's going to hash the password 2 raised to the power 10 times. So you need to be careful with this value you are passing. If the value is too high, you're going to spend, your system will be slow because you're going to spend a lot of time trying to hash passwords. So you have to keep it moderate. If it's too low, it's not secure enough. So you have to be careful about this number. So at this point, we've hashed our password. If it's successful, what happens is that this will be triggered. This next callback will be triggered. So we've been able to hash the password. Next thing to do is to save it, right? So we have a user model. I created this user model in the MongoDB. It takes a username. It takes a password and a row. Like I said, the username is a string. It's supposed to be unique. It's supposed to be required. It can't be empty. The password too is supposed to be a string. More than 6 characters is required, right? And then a row. The row too is also a string. If you don't pass in a row, we assign one of a basic row, which means you're not an admin. Also required. So that's how the user schema is. Hopefully, you're aware of how these things work. So back to our register function. So this is where we save the user in the database. So at this point, you save the hashed password. There's no more the password the person sends. One that has been hashed, you saved the username and saved the row. Now, when this is successful, the next thing we do is to use the JWT we spoke about. So one of the uses of the JWT is that we don't want people to keep logging in. Just assume you log into your email and then you change tabs, you go to YouTube, you come back, and your Gmail tells you to log in again. Then you go and come back. Like imagine anytime you switch tabs, Gmail tells you to log in. It's going to be very, very annoying. It's very similar to the band and the swimming pool example I gave. Imagine you're swimming, someone tells you that, hey, have you paid? Then you be like, oh, you have paid. He says, how? Then he asks you, how do I know you've paid? Yeah, and you have to follow him to the reception. The receptionist will say, oh, he has paid. It's a long process, right? We want to avoid that. So whenever we are able to authenticate someone, prove that yes, this person is allowed to the system, next thing we want to do is to generate and sign a JWT. Then the JWT will be sent to your browser. Now, anytime your browser is trying to do anything on the server, it will send the JWT. So when it sends the JWT, we're going to check the JWT your browser is sending, and then we have, if they are the same, it means you've already logged in before. So we can allow you to work without asking you to log in again, right? So that's a JWT. To sign a JWT, it takes, these are the three parameters that you need to provide. The first parameter is the payload. The payload is any information that can help you identify a user, right? So, but note, you shouldn't put in any passwords in the payload. Nothing critical, right? It's just something, just enough to be able to differentiate that this is person A in our system, this person B, right? So the very first, the payload I'm passing is the ID that is generated when you add a user. MongoDB generates an ID for you. So I'm getting that ID. I'm getting the username you used to register, and then the role. That's the payload I'm going to add to the JWT. Then I'm also going to pass in something called the JWT secret. The secret is nothing but random numbers, right? You can just write anything you want, really. It's just random numbers. This is what my JWT looks like. They're just random numbers. It has no meaning. It just has to be secure and has to be long enough so that people cannot guess it. Because when they're able to guess it, they get you, right? So that's how the secret looks like. It's just a string. And then this one is how long the the JWT should last. You realize that sometimes you log into a system, you switch tabs. After 30 minutes, you come back, it tells you that your session has expired, so log in again. Yeah, it's because your token's lifespan has expired, right? For this one, I'm setting it to 3 hours. So I use this to sign the JWT and I get a token, right? When I get the token, we are now going to pass the token back to the client. So you are saying that we've checked you, we are okay with your identity and everything. You're allowed to use the system. So take this receipt, and whenever you're coming, bring it. So we know that we've already checked you. So we don't have to check you again. So to do that, to send it back, you have to pass in the token as a cookie. You're passing it into the cookie. The cookie is just a storage area, a very small storage area in your browser, right? And it's just made up of key and value pairs. So it has, the key is what you use to identify it, and the value is the actual thing in it. So the key I'm using is the JWT. The value is the token that was generated after we sign all of this and generates a random long string. Now these things are very important in a cookie because they help secure your cookie. If someone can get access to your cookie, but they shouldn't be able to necessarily read and understand the things in it because it contains your token. So imagine this: someone has logged in, authenticated themselves and everything. We've generated a token for the person, and then somehow I'm able to copy. I don't need to know the person's password, the person's username. I don't need to know anything about the person. All I need to do is to be able to steal the person's cookie because the cookie says that we've already identified you. So exactly, imagine that you give receipts to someone and then I can steal the receipts. The receipt doesn't have anything that can tell that this receipt belongs to. Like, it doesn't have my picture, it doesn't have my name, or it has my name, but it doesn't have my picture. I can take the person's receipt and say, that name is mine. How would you know? So if someone gets your token, they can impersonate you and use it to get access to your system without knowing your password. They don't need to guess your long password. They just need to be able to steal your token. So you have to make sure you are securing your token, right? So you set this property secure to true, and you set it to okay. So what the HTTP only does is that if you set the HTTP only to true, it's going to prevent any JavaScript code from accessing the cookie. So if anyone writes any piece of code trying to access the cookie, it's going to stop them from it. They can't even run scripts on your cookie to read it or decrypt it or something. They can't. If you set it to secure, what it means is that the cookie is only going to be passed if the connection is an HTTPS connection. If it's not an HTTPS connection, the cookie will not be passed. So that's what the secure does. The maximum H2 is how long this cookie can stay in how long the token can be in the cookie, basically. So yeah, so we are sending a cookie back to the client. And then when you're done with everything, we tell the clients that it was successful, right? The registration was successful. If for any reason we got any error, we send wasn't a successful registration. So an example of that. So we have our endpoint here, right? So the API login.register, and I'm using a username test2, for instance. The password is test12345. Simple. And I'm saying that I'm an admin. I'm trying to register. I do that, and everything, it goes through the whole process. So at this point, we actually have the cookie I was talking about. And this is the ID that's generated. This is the hashed password. The hashing password. This is what we have after hashing. Then the cookie, you can see the cookie here. See, the cookie's name was JWT, and this is the value of the cookie, right? And we have this HTTP only, the secure, then the expired lifetime. So yeah, that works nicely. We've implemented authentication, right? Let's go to the login. Well, we've known to register. I'll come to now authenticate if someone's trying to log in, right? So we have this user just created. Use that user here and the password. Let's go to the password code. Let me explain what's going on here. So as usual, there's a logic that gets executed if you log in, right? 40 minutes, 20 minutes more. So as usual, we get the parameters you're looking for, the username and the password. For my system, it's a username and a password. You can try to use an email, whatever, but yeah, we are getting the username and the password. As usual, I have to validate, make sure that it's what you're expecting it to be. So I'm validating to make sure that it's not empty. Both the username and the password are not empty. If they are, it will tell you to provide username and password. So if that is set, we are sure that the person has provided a username, person has a password. Next thing is you're going to look for the person in our database. We're trying to make sure that the person is allowed to access our system. So user.find1 is going to look in our database and find the person if he exists, right? So if that executes and the person is in a system, this user object would not be null, right? So if it's not null, we are sure that we've already saved the person's username in our system. So once the person has been verified that the person is in our database, the next thing to do as usual is to send in the token to say that we verified this guy. This guy can continue to use our system for a number of time. So a similar thing, we are trying to sign a JWT and pass it through the cookie. A similar thing in the registration. If there's any error, we let the user know, right? Now, if we know that the username is in the system, we've passed in a cookie to the person, we want to now compare the password. Make sure that the password the person passed is accurate or not. Okay. Make sure the password the person uses is accurate or not. So we are using the same bcrypts we used to hash the passwords. We're going to, it has a compare method you can call to check the one coming from the front end and the one we have in our database, check and make sure that the two are the same. If they are the same, for what's going to do is I'm going to hash the other password and add the password salt and then just check and compare if they are the same. Then it tells you that the login was successful. If they are not, then it tells you that your password is wrong. So it actually doesn't let you go on to the next stage. Yeah, that is it for the login and the register. For the updates, if you want to change your role, for instance, you want to update to an admin, we go to, I don't think this part is has anything to do with security. It's just a bit of code I just added. So that is it for the login and then the authentication. The next thing is the authorization. So we want, so imagine you've built your API, right? You have your endpoints. If you don't kind of prevent certain people from accessing certain endpoints, anybody can do anything at all. If anybody knows, for instance, let's say for my system, I don't want a basic user to be able to delete someone or update someone's role. So I want to make sure these two middlewares are only called if the role is an admin. Then it means I have to kind of secure just these two endpoints. So I'll allow anybody into my system, but I'm going to allow only the admins to be able to update and to be able to delete, right? So I'm going to sort of secure these two. Now we're going to use the JWT to implement that logic, right? So I have a middleware I'm calling admin JWT auth. This is going to kind of authenticate. You're going to authorize, basically check if you are authorized to access a certain route. So what it's going to do is I'm going to read the cookie you are sending. If you try to access the update, for example, it's going to read the cookie you are sending. It's going to verify if the cookie you are sending is what we have to make sure that you're allowed to access. Remember, when you're assigning the token, you're also assigning the rule. So it checks that basically it's able to verify that you are authorized and you can access the updates. It will just return if there's an error. It tells you that the token are not the same, right? If there's no error, and it's going to check that you're an admin. Again, it's just extra precaution. If it checks and you're an admin, it just goes to the next middleware, right? This one is basically saying that, okay, you passed through our checks, you are fine. You can go to where you are going. I have a similar thing too for the user. I mean, the basic user. We're going to check your JWT, verify that you are allowed to use the route you are going to, and then we allow you. Now, where do we call these two things? Now, you call these two middlewares whenever you want to kind of the path you're trying to block, and you call them there. And this is here. You find this here. So if you hit my endpoints with this route, yeah, it's going to first try to authenticate you if you're an admin. If you hit this basic route, it's going to try to authenticate you if that's your user. If these things fail, you're not going to, let's assume this is the admin's homepage and this is the user's homepage. If any of these two things fail, you're not going to see the homepage. So you're not going to be allowed to enter the system. So let's just do a simple login. So we created this guy right now, and this guy has been able to log in, right? And mind you, we have the cookie here. So when we go to, let's go to, where's the update? Oh, I registered as an admin. So I'll be able to update. That's fine. If I go to the update routes /updates, it was able to authenticate me because I have the JWT, right? And it's allowing me to, oh, my role is not an admin role. Okay, let's just go ahead. So if you're an admin, it's going to allow you to go all the way to the admin route. If you're a user, it's going to also allow you to go to the user's route. The next important thing to note is that you don't let your cookie stay on you don't allow your cookie to stay forever. That's why it's good to be careful when using like public systems. Make sure you log out when you're off your PC, because if, for instance, you think all it takes to log into your system is your password, so you have a very long password and you keep it in your head, and then you go and log into a system, and the system has like the JWT, the system has your token lifespan to be very long. And then you log into you go to a cafe, you log in and you finish and you don't log out, right? Or the system doesn't implement a good logout functionality. What's going to happen is that the token is going to live on the browser. Anybody who knows what they are doing can just open the cookies, check. Most of the times the cookies have like the website name you are trying to access, the token and all those things. If they see something like that, they can just use your token. You can just copy your token and then use that to log into your website. If it's your bank, for instance, just copy cookie and use to log in. They don't need your password. Once they have the cookie, that's it. So you make sure you implement a good logout. Basically, what a logout does is that it's going to clear whatever is in the cookie, right? If you hit the logout, it's going to clear whatever is in the cookie and then sets the lifespan to just 1 millisecond. So basically, it clears the cookie or your cache. And we can see that here. So this is a logout. If we log out and we check the cookie, realize that it's gone back to 0, it's cleared it. So nobody can have access to our cookie, and then it redirects us to our home page or login page or whatever. So I guess this is it for the demo. Let me see if I have something on the slides. Then we are done. Yes, so I've explained the hashing and the sorts, and this is what the hash key looks like. And these are the parts of the hash key that the bcrypt gives us. We've already gone through this. And yeah, that's it for me. Does anyone have any question? You can go ahead and ask.
Okay. Hello, Emmanuel. So thank you for that. So guys, if you have any questions, please go ahead and ask your questions. If you don't understand, feel free to ask Emmanuel. Let him know and answer your questions. So you can start dropping your questions now, or if you feel like you're going to speak, just raise up your hand and we'll allow you to speak. So, okay, we have Samuel, Temtokwe, Bendex, Emmanuel. Okay, no issue. Okay, Green. I think, okay. I think we have one person here.
Yeah, so the question is, can we use other database with Node.js apart from MongoDB? Oh, yes. You can use any database at all you know of. All the databases you have in mind, you can use any of them. You can even change some of them. There are some hybrid systems that I don't use, like just one database. I've seen some database, there are some systems that can maybe use SQL and MongoDB. Does CSEF help with this? I don't know what CSEF is. I would have to figure out what CSEF is, so I can't tell. Sorry. But if you say, does it help with this, what do you mean by this? Like authentication, security? What does this mean? But I also need to know the CSEF because I've not come across it before. Any other question? Oh, okay. It's used to create a token. Then if it works with the same principle, then yes. I mean, JWT is not the only one you can use to create tokens. So if the CSEF does that, yes, then by all means, go ahead. But make sure you are reading the documentation and then see the limitations as well. So yeah, Samuel, that's your answer. Any more questions? One issue with creating another cluster in your database. So that's why you want to move to another bit. Oh, sure. Yeah, feel free to move to any database you want, but moving just because you're having issues is not the best way forward, right? There are so many things to consider. So try and find a solution. If you can't, then you can just go ahead, right? But try and find a solution. Or if you have other reasons to migrate to another database, that's fine. Anything else?
So I think that's the last question. Yeah. So guys, you can go ahead to say thank you to Emmanuel. I'll be dropping his LinkedIn handle so you can follow him on LinkedIn. You can connect with him on LinkedIn and feel free to ask him any question you want to ask. I think someone just dropped one question.
Yeah, it's a MongoDB question. Actually, I'm not a Mongo person, but to be able to figure out the issue, you have to see what you are seeing. I don't know the error you're getting. So you can hit me up on LinkedIn. I can recommend some Mongo people to help you. So yeah, you're welcome. Yeah, I guess that's it.
Yeah, the class was explanatory and straightforward. So thank you so much, Emmanuel, for today's
Thank you for
class.
having me.
Take
All
your
right.
All right. So good night to you, and good day, good morning, good afternoon, good night, whatever your time is. Have a lovely day,
All right.
everyone. Bye,
Bye.
guys. Okay. All right. Okay, someone, is there a possibility of sharing the file? I think he already left. So no problem. I'll reach out to him and ask him if he could share the file. If I get it from him, I will share it on Discord.